Hi everybody, it's a really pleasure to be here, and thanks again to E.S.PKU for the invitation. So I have a bit different background, and I will speak of course about PKU because we are E.S.PKU, but I decided to change a bit my presentation this morning because I think we should speak more about in general normal aging. So I will, because the conclusion is that, of course, PKU is special, but it's not so different. Okay. Okay. So I'm a neurologist. My specialization is so the biomarkers in neurodegenerative disease, and so I started the story with the PKU because. We were scared about an increased risk of neurodegeneration in PKU patients. So, of course, we are always scared about a lot of things. And I had in my family 3 grandparents with neurodegenerative disease. So, I mean, we all have an increased risk of something. But I will tell you that so we should be positive and think about not only about neurodegeneration but successful aging in PKU patients. Okay, so we still don't know exactly what is normal aging, but of course we know that there are a lot of differences between old subjects and young subjects in terms of motor and cognitive performance. And what are the rules for successful aging? We still don't know, of course, but we know that the brain plays an important role in that. So the selective vulnerability of different brain regions play an important role in that, but also what we do is very, very important in order to understand how can we compensate to certain neurodegenerative disease or neurological disorder. So we have from one side the brain reserve, as you can see here, and on the other side what can we do, so cognitive reserve. And we spend more details about also what we can do against or for a successful aging in PKU, but not so in general. What is very important is that the brain in general, so every subject through aging, during aging, has a lot of different modification. And it is normal to show decrease in the white and gray matter volume of different regions, for example in temporal or frontal lobes. But during a normal aging, there are no neurological deficits, and of course we can have a very slight decrease in motor and cognitive function, but there are no neurological deficits. On the other hand, neurodegenerative disease are, of course, a group of different conditions, and these conditions are characterized by the accumulation of different proteins in the brain. So aging, normal aging, is a risk factor for neurodegenerative disease. So, of course, most neurodegenerative disease have a higher prevalence in older people, especially Alzheimer's and Parkinson's disease. But there are also rarer causes of neurodegenerative disease like amyotrophic lateral sclerosis, Huntington's disease, also genetic neurodegenerative disease. Okay, and there is a big and huge difference between normal aging and neurodegeneration. With the idea that PKU brain is fragile, so has an increased vulnerability, we started this small study in Germany, and I have to thank a lot of patients. I know that some are here, because from this study we learn something more about the connection between PKU brain and neurodegeneration, but also the connection between PKU and aging and metabolic control. And so we start with the idea, okay, let's test the biomarker of Alzheimer's disease and Parkinson's disease in PKU older patients in order to see whether they have an increased risk of neurodegeneration. And we were all scared, and the patients were scared about that. So the very classical markers of Alzheimer's disease, so the very gold standard markers of Alzheimer's disease with an accuracy above 90% are the CSF markers. And I have to thank the patients who underwent a lumbar puncture in order to test these markers in CSF, so in cerebrospinal fluid. And from the other hand, or from the other side, for Parkinson's disease, there are no clear markers. There is a combination of no motor symptoms, and we also tested them in the study. So here, just 3 slides in order to show you what we found, the very key point. So in CSF, we found a very clear correlation between phenylalanine, so between plasma and CSF phenylalanine. So this is again important to show you that phenylalanine in plasma is a good proxy of phenylalanine in the brain. Not always, I know, but in general we can use that. And in the other, so on the right side, you can see that there was a reduction in serotoninergic pathway levels in PKU patients, and in very few patients also dopaminergic levels. And there was a very good correlation between metabolic control in adulthood and serotoninergic and dopaminergic level. Still, I have to say that I did not find any clinical correlation between the serotoninergic level and the features of cognitive feature or behavioral feature. Of course, the numbers are small, but there was not a clear correlation. And here is a very, very good result for we all, because we found that there was no increased risk of Alzheimer's disease in PKU patients. So the most important of this marker is AB142, because it's very sensitive, also 20 years before Alzheimer's disease. And as you can see, healthy control has a decrease, a significant decrease of A-beta against PKU. And so the healthy controls were worse than PKU patients. So there is no risk at all of classical Alzheimer's disease in PKU patients. Okay? And what about the non-motor symptoms, so Parkinson's disease markers? Of course, there are some patients with some symptoms. I still don't know what is depending on brain phenylalanine accumulation and what is due to dietary or what is unspecific, and so we have to gain and to have more patients in order to understand what does it mean. But again, we did not have a lot of positive Parkinson markers in our cohort. And what about brain atrophy? So, because we are interested in understanding whether there is a correlation between dietary control in adulthood and specific vulnerability of some regions in the brain. And these are the results. So, higher phenylalanine level in adulthood correlated with a greater atrophy in a very small region of the brain. So, and this is so-called parietal cortex, so precuneus cortex. We know that this region is a very common and shared region of vulnerability for a lot of different conditions, for Alzheimer's disease, for dementia with Lewy bodies, but also for normal aging. So it is normal to have a decreased volume in this region. And what we can think is that the increase of phenylalanine will increase the vulnerability of this already vulnerable region we have. Okay, and of course it is too small to correlate with symptoms or with cognitive function, but still it is an important result. And if you see a lot of different non-motor symptoms, they correlated with higher level of phenylalanine. But of course, we still don't know the mechanism underlying that. So, what can we learn from this part of presentation? That there is no increased risk of Alzheimer's disease in PKU patients. I'm sure about that because we have no patient with a beta level under the score and the limit we used in the clinical practice, but Phe levels in adulthood correlated with an increased vulnerability of some regions in the brain. And so I decided to give you this overview or this idea, is that the PKU brain, of course, is special, but is not very different. So, what can we do for a successful aging in PKU? Again, what in general, so for me and for every person in the world, what can we learn about the publication in the last 5-10 years? So I will speak more about Alzheimer's disease, not because I think that Alzheimer's disease is the problem of PKU, but because for numbers of publication we have a huge amount of data, and we learned a lot in the last 10 years about the risk factors of Alzheimer's disease. And I will show you that Alzheimer's incidence is lowering now, and this is a very important point. And so we have a lot of different risk factors for dementia in general. So Alzheimer's disease is the most common one, but there is also vascular dementia, so there is a group, but 60 to 70% of dementia patients are Alzheimer's disease. And we know that, of course, unhealthy diet, smoking and alcohol are risk factors of dementia, and but we have also protective factors. So the education, diet again, but also physical activity, cognitive activity, social skills, and brain reserve in general are really an important protective factors for dementia. And in the middle age, the control of hypertension, diabetes, hypercholesterolemia, so the classical vascular risk factors, is really, really important for decreasing the risk of dementia. And this can explain why we are now seeing a decrease in the incidence of dementia. So, about sport, what can we know? We know that sport can decrease the mortality rates. But of course, sport is also a weapon, so we should not do sport at a higher intensity, because we know that a high intensity sport can paradoxically increase the mortality rate for a lot of consequences, negative consequences of sport. And so there is a very important balance between a good sport activity and too much sport, but in general I will suggest you all able to do sport. Sometimes I have no time to do that, but when I have the time is really better for everything. Also for my cognitive performance and to do research is better to give you 2, 4, 5 hours sport per week. What about cognitive inactivity? Because we all have television and we don't have always a lot of time to be always on reading a book. But we know that cognitive inactivity is a very important problem for us. And we have now a lot of new instruments for cognitive rehabilitation, so not only in the clinic, but also at home. And what I found very interesting is that the efficacy of cognitive training at home is of course is good, but is not as good as the cognitive training in the clinic or in the groups. And why? Because we know that there is another very important point, this is socialization, and so to do training together is really better than to do training alone. And for example, in Alzheimer's disease, this is a very beautiful study, I think. So they teach some Alzheimer's patients to do grandparents to the children. So they were alone, they were grandparents without NIFLI, and they had new children and they had to teach to the children. So it was good for the children, it was good also for the new grandparents. And this showed a very good efficacy in the prevention of cognitive deterioration in Alzheimer's patients. But very for us, so for expert in neurodegeneration, the very most important trial I think in the last 5 years was the so-called finger trial. And so the finger trial was a multidimensional trial in Finland, in Scandinavia. So they tried to ameliorate the condition of patients affected by mild cognitive impairment, so the very early phases of Alzheimer's disease, through a combination of diet, cognitive training, exercise, and control of vascular risk factor and social activities. And the results were huge, because they showed in a very short time, because it was 1 year, 2 years, so there are follow-up, but they showed a very clear efficacy, not only in general in quality of life, but also in very specific, so in terms of cognitive function. Okay. And so this explains why, of course, so the dementia cases we will see are increasing. Why? Because we are getting older. But as you can see here, the numbers, or the pure numbers of patients with dementia, so the incidence of new cases is decreasing. And so if we adjust for the age, actually the incidence of dementia in general and Alzheimer's disease is decreasing. And this is a very important point that I want to stress. But can the brain always learn? So when we are 60, when we are 70, can we compensate the damage or not? And I found these two studies very, very interesting, because we have a different cells for different for the perception of colors. So we have 3 different cones. There are neurons specific for red, green, and blue reading. Okay, but through aging, we are losing them in an asymmetrical way. So as you can see here, we are losing more blue cones. Okay, so we are expecting maybe that when we are getting older, we cannot see the blue things as when we are young. But it's very, very interesting that actually the brain compensates this loss of neuron because it understands that the blue is no more the blue we have to see. So it understands that something is getting wrong and it compensates it. And I think this is a very, very beautiful example of compensation through aging. Okay? And on the other hand, the brain of adults or older people can even perform better compared with young person in some complex multitask objective. So here there is a very interesting experiment. So you hear a sound and you have a figure, and then you have to say if they are fitting or not. So in this study they tested that in young and old subjects, healthy subjects, and they showed that the old subjects were better in the combination of sound and figure compared to young subjects. Why? So it's quite strange, but it is not so strange because of course when we are 50 and when we are 60, we learn a lot in our lifespan. So the connection between the different regions of the brain are very trained, and so we are better than a young person in performing the multitask tasks. So this is the reason why we use a lot of multidimensional and training in old patients because they have a very good efficacy. So for example, with the sport and sound or visual skill. So this is a very, very important concept. So just to conclude, again, there is not an increase in the risk of Alzheimer's disease in PKU patients. PKU brain is, of course, something special, but is not so different from our brain. And the brain can always learn and be trained. And there are, of course, several strategies for successful aging. So, of course, we have a lot of questions still. And because we should understand a bit more about the vulnerability of the brain in PKU, so the peculiarity of the brain vulnerability in PKU, but we should not forget that we should actively do something, and what we can learn from neurodegeneration in general is to go ahead and to go with multidimensional training in order to increase our cognitive reserve. In order to understand a bit more, I start now in Italy, because I'm back from Germany, a project with patients older than 30 years. So if you're interested, just write me with new markers and of course no more lumbar puncture because we learned a lot already. I have to thank a lot of person really